Yeah, you told me. I just don't want to tell you about it.
33.
Gabe, you already spilled it to me.
You gotta read it to me.
How many ways can a jury of 8 men and 8 women be selected from 12 men and 10 women? Yeah.
Again, what do you know as you're looking through your test?
We should try studying a little harder.
What's Brian know? And I'm gonna take that phone away from him if he doesn't put it away.
Where's Wade?
What do you know about your test? Everybody's looking for number 33 and nobody even remembers all the way back to last week.
So you got 8 men, 8 women, you got 12 total men.
You choosing from 12 men. Doesn't matter what order those men are chosen in.
No.
So it's a combination. Choosing 12. How many you
12,
taking?
you're choosing 8 men out of 12.
So from 12 men, you're taking
8.
8. And for the women, what's it going to be? 10 C, 8. And what do you do with those two? Multiply. If, I don't remember if this, I don't think this was a multiple choice question, I don't remember. If it's not a multiple choice question and it's like this, if you show me this, I give you some of the points. All right, even if you messed it up. Because I think several people messed this one up because instead of multiplying, what'd they do here? You added, and it should be multiplication. What's it come out to be if you multiply it? Do we want to do them separately? And then multiply, or do we want to do it all at once? Just do it all at once. Do it all at once? Somebody give me the answer.
22,275.
22,275?
Yeah.
Anybody else get that? Is that all they ask us for, is how many different ways? Or did they ask us for probability or anything, or nothing? So that's it?
5.
I don't have it, but does she still have it?
5 gauge?
5. The probability of A equals 3/5. Find the odds of winning
C. 3, 2.
Again, let's try to do this again. I got it. As I'm doing this problem, are they all going to be the same?
No. 3 wins.
So, just because I do this problem, does that mean that Ben's going to find this answer on his desk somewhere?
Should.
You guys didn't figure it out when doing the test together?
They weren't the same.
We should find the same answer, just not the same answer.
I think some of them are completely different, weren't they? So they want the odds this time. Remember, odds are wins compared to losses. So if the probability of A is 3 out of 5, how many wins do you have? 3. How many losses do you have? 2.
That makes sense.
That's crazy. You guys did the review back.
Hey, maybe Sean can shut up. Hey, Sim, move your knee. Is it your right?
Go ahead, keep
See this
it.
full range of motion.
If the student selected a random, find the probability that he or she owns a credit card, given that the student is a sophomore, trying to answer the 3 answers.
So given that the student's a sophomore, so we're picking from what? Just the sophomore. So as I look at this chart that's on Ben's test, there's a total of 40 sophomores. They want the ones that have a credit card. So on his ones that carry a credit card, there was 28. So 28 out of 40. What do you have to do to that? Change it to a decimal. Somebody do that for us. What is it? 0.7. Anybody else get 0.7? Is that what it gave your answer as? Is it decimal or percent or what? Decimal. Next question. Read it, Jim.
Find the probability of answering two multiple choice questions correctly if a random guess is made. Assume the questions have 5 choices for each answer and only one choice is correct.
All right, so like maybe on several of your guys' tests, there's at least 2 multiple choice, right? And you want the probability that you get the first one correct and the probability that you get the second one correct. So what are we gonna do with those 2 probabilities? What's the probability you get the first one correct? 1 out of 5. What's the probability you get the second one correct? What is it? 1 out of 5. Did this say correct? Because I know someone said incorrect. Did it say correct?
It said only one of the choices. Oh,
Yeah.
it says only one of the choices is correct.
But did it say we want the probability you get both of them correct?
Only
Is that
one.
what it
Only
said?
one of the choices is correct.
Yeah, that's what I.
That's what we're looking for.
Right, but did it,
Find the probability of answering the 2 multiple choice questions correctly.
all right, that's on, all right, so only, what they're saying when they're saying only one choice is correct is 1 out of the 5 choices are
Okay.
correct. So if it goes A, B, C, D, E, it means A and B aren't both correct, only one of them's correct.
Oh, shoot.
What's 1 times 1? 5 times 5? They give you, so 1 out of 25 chance of getting both of them correct. Do they give it to you as a decimal, a fraction, a percent, what? Decimal? Somebody help us out. 0.04? So if you're guessing, you get about a 4% chance of getting 2 multiple choice questions correct.
It's pretty good. Yeah, it's one out of the 8.
The probability it will rain is 40% each day over a 3-day period. What is the probability it would not rain at least 1 of the 3 days?
So probability it rains today is 40%. Probability it rains tomorrow is 40%. Probability it rains the next day is 40%. We want the probability that it what?
It will not rain at least 1 of the 3 days.
So no rain 1 of the 3 days.
If someone came and asked me this question, like truthfully, like, I would tell them that they have a good chance that it's not gonna rain. That's why, I wouldn't give any numbers.
Yeah, see, and I would think that that's not, when they tell you it's, if there's a 40% chance of rain, do you think it's gonna rain?
No.
I think most people would think, yeah. If the newscaster, if the weather person's saying 40% chance of rain today, most people are thinking it's gonna rain today, even though that's less than half the time.
It's less than 67%.
Right? We want the probability that there's no rain 1 of the days. Could we do this? 60% times 60% times 60%? Because what's the probability that it doesn't rain on a day? 60% of the time. Could we just multiply those 3 together and get the answer? That's the this is gonna give us the probability that what?
It'll rain on all 3.
It doesn't rain on all 3. That's not what we want. We want just 1 of the days to be a nice day. So how could we do that?
60-40, is that? Or what?
If it's just one of the.
Then that would give us
1 day.
just 1 of the days and not
Shouldn't be.
2 or 3.
40, 60. So if it's just
If
one
it-
nice
if it's,
day.
if it's 40, 40, 60, then that's gonna give us, you're saying it rains first day, it rains the second day, it doesn't rain the third, so how many days clear do we have? We want Is one the only one we want?
We get 1, 2, or 3.
We want probability 1, 2, or all three no rain. What could we do? How many, look at what we have here. What's the only other possible outcome?
It rains 2 of the days.
One or two.
Oh, it rains.
All 3 days. So that's the only other possible outcome is it rains all 3 days. What's the probability it rains on the first day? 40%, so 0.40. What's the probability it rains on the second day? Third day? This is gonna give us the probability it rains all 3 days, right? We don't want the probability it rains all 3 days. We want everything else. What are we gonna do once we get this answer? What's the total? Always in probability. Or 1. Somebody multiply that out. What's 0.4 times 0.4 times 0.4? That's gonna give us a probability it rains 3 days. We don't want it to rain all 3 days. We want anything else other than that. What'd that come out to be? 0.064. Subtract those two, what do we come up with? Stuff we're going to get into today in this next chapter, this is what we got to know. We got to be able to think things through this way. And I know it's hard sometimes, but you got to be able to think them through and say, okay, I don't want just the probability it rains 1 day or 2 days or 3 days. I want what's the probability that any of those things happen. What does it come out to be?
0.36.
So if we're trying to set up Gage's birthday party, and we got those 3 days to pick from, and we're doing it outside because we gotta have a bouncy house, right? Because Gage can't have a birthday party without a bouncy house.
It's probably the truth.
So, do we have a pretty good shot in those 3 days, even though the weatherman said there's a 40% chance of rain all 3?
Yeah.
Yeah, there's a pretty good shot that one of those 3 is not gonna have rain.
I still don't.
It didn't read it at all.
Plan a birthday for 30 days.
Yeah, I don't think it rains at all.
40% chance.
Yeah, if I'm going out with a shirt on, if it's 40% chance of rain, it's not gonna
I'm
rain.
glad you have a shirt on. Everybody in the world's happy that Phoenix is
I
wearing
said
a
just
shirt.
a shirt.
He's got 2 shirts on.
I know. That always makes us twice as happy. Long pants too. All the females are completely happy too, Phoenix.
They don't wanna see my big calves.
I guess the answer is-
Let's just die over there.
Other questions?
No, I got 28 right, but I switched it up. I'm looking.
It's just the fun.
Yeah, I did the last part wrong. I was like, I don't like all those decimals. Like, I'm moving the decimal. Oh, 35.
Read it to me.
In the California State Lottery, you must select 6 numbers from 52 numbers to win the big prize. The numbers do not have to be in particular order. What is the probability that you will win the big prize if you win 1 ticket? If you buy 1 ticket? 33, 5.
So we're buying 1 ticket.
Yep.
It doesn't matter what order the numbers are in, so permutations or combinations. How many numbers we picking from?
52.
How many we taking? Might help us out.
Total 2, 0, 3, 3, 5, 8, 5, 2, 0.
Anybody else get that?
Yes.
Now, is that our answer?
No,
We just
it's one in that.
So we got.
So our probability, the probability that we win
It's 1 out of 29,315,000.
is 1 out of that.
So that blows, dude. 'Cause
We got that one right.
That blows.
Did we get that one wrong?
Put it under 1.
Yeah.
We forgot to put ours under one.
That's what I did too.
Oh, that's so.
See,
that
Michael,
sucks.
we would have had a better grade if we just thought more.
If
you
we
know?
wouldn't have been rushing.
That might be the most Einstein
No, you make
thing
me
I've ever
smile and
heard
make my
somebody
day,
say.
that's all.
We should write that down somewhere. We might have had a better grade if we would have thought more. We need to post that somewhere.
If we would have taken more time.
If we would have taken some time.
And like, look, if
It
we
would've
would
been
have
alright.
checked our
Right, yeah,
answers,
right
it
above.
would have been like, hey,
Wait a minute, we should put that
Wait a
one over
minute.
that.
Laws of Phoenix. That's what we're gonna start. Laws of Phoenix. First one, first law. We might have got a better grade if we would have
you might
thought
get a better
more.
grade if you think more.
Other
If
questions?
one wants better grade, one must think more. That'd be the law. No, those are the ones I
He
got.
wrote it as an if and then statement. I taught him something in geometry. I swear I taught him something. He wrote it as a conditional statement.
No, all the other ones I got wrong, I got wrong for stupid reasons.
Just wasn't thinking.
I wasn't thinking enough.
Remind me towards the end of class. I'm gonna give you a chance to score some extra points on your test. All right? So remind me when we get down to the end. Set those off to the side for now. Well, we're gonna start covering Chapter 4, Discrete Probability Distribution. Discrete Probability Distribution. I'm gonna write it up here. It's the wrong thing. I'm gonna tell you that. So the title, Discrete Probability Distribution. She brought this in too, so I sent out the answers to a packet we're doing in geometry. One of the students printed off the answers so that they could copy them down, which is fine, but if I get it before they get it, it goes in the trash.
They printed it off again.
Yeah. Phoenix, I'm just hoping that they're using their brains like the all-wise Phoenix would use and print it off again. I have this bad feeling.
They didn't print it off
They
again.
won't print it off again. I don't know. You guys, this class is probably not the last one I sort of have faith in.
That's a W for.
And guess what? You know what's more in-
That was not Ebersole that said that. That was Sean. I'm not sure why he said it, but sort of sounded like Ebersole. How'd you do that, Sean? You sound like my voice.
You just inspire me so much.
It's a great impression. If you're gonna cheat, at least like, don't print to like Windows printer. Print to the library or something.
I don't, are you even allowed to print to Windows printer?
I wouldn't do it just because it's Windows printer.
I'm in Wendell's room.
Yeah, yeah.
If you're in his class, yeah.
If you're in there,
But-
but you just
I
print
see.
it on his printer.
When I'm in accounting, the teacher's always coming in.
Well, yeah, that's
I know the teachers do, I know they.
Oh, you're talking about students?
Yeah.
Yeah, probably not.
I would never print a
Well,
Windows
as far as
printer.
class-
I printed the Windows printer one time, it was because Mrs. Spiner told me to.
I would say his intervention, we weren't allowed to leave to go to the library. If we needed a paper, we had to print
Print
it.
it to that.
If you're in his room, you print it to his room.
I would understand if you're in his intervention. I didn't even know that his printer was one of them that you guys had a choice of.
Yeah, we can,
It's
we have choice in every single printer.
But some are just blocked.
Yeah. Like the counselor or whatever.
The copier.
That one.
It's kind of always down there and it's hot in that room,
Down in the counselor's room?
burning hot in there when the copier's going.
Amazing. Alright, so with this. Start of the year. We started off and we made stuff like this. Anybody remember what these were called?
Frequency distribution chart?
I don't even have to finish it. He finished it. Frequency distribution chart. That's what we're gonna sort of do again, except now we're doing probabilities. Alright? With this, you're dealing with a random variable, so we're just saying something at random. It's not anything, you know, what's the chance? And I'll show you some, and it's not near as hard as I'm making out to be right at this moment. It's hard for me to explain without showing you everything all at once. If we're rolling a die, what are the different possible outcomes? 1 through 6. Instead of class here, that's what we're gonna have here.
All the possible outcomes.
All the possible outcomes.
Could be a lot.
Alright, it could be a bunch, but probably not, we're not gonna, just like
So
when
one of
we,
these tables that we're.
Can we do this on the calculator?
when we did classes, we did like, right, 5 to 7, or 4 to 7, something like that, we kept them short so that we could actually do it here. Now, you're right, it could be a lot, we're not gonna do a whole bunch, you know, we're not gonna do it where you got 15 possible outcomes, it's not, that makes sense. So we're gonna do that, and what you're gonna have is the probability of each one. Now, when we get down through all these probabilities, what's gonna happen?
Out of 2, 1.
So the frequency, you're gonna have your frequency here, just like we did on the others. But the probabilities down here should always add up to 1. Okay, so we're gonna have that. Now, when we were just doing that problem about the rain, we could do that problem this way, and then instead of going through what we did and saying 1 minus, it rains all 3 days, we could go down through here and pick out, okay, we want when it rains, the probability when it rains 1 day, probability when it rains 2 days, or the probability when it rains 0 days. And we could add up those probabilities. And instead of doing it the way we did it, guess what it's gonna add up to? 97.973 or whatever it was. So we can do it that way. That's what this is. Our variable here, this is gonna be our X. Some books use a big X for the whole group, and then a little x for each one separately. This book just uses X, so we're not worried about capital X or small x. That's just gonna be our variable. An example, number of sales call a salesperson makes in 1 day. We're gonna let that be our variable here, our random variable that we're looking at. How many sales calls does that salesperson make in 1 day? Could be 0, could be 1, could be 2, could be 3, could be, if your gauge, could be like 72, right? Because he's on it.
Yeah, so he's.
Company man.
Need a raise.
Got extended warranty.
Discrete random variable. We're going to talk about 2 different kinds of random variables. One of them is a discrete, Then we'll talk about the other one, just deal with discrete for now. A discrete random variable has a discrete or a finite amount of possible outcomes. The main thing for discrete random variable it can be counted. So the outcomes can be counted. The possible outcomes can be counted. There's one possible outcome, two possible outcomes, three possible outcomes, four possible outcomes. I know Riley's going, well, that doesn't make any sense. And he's right. It'll make sense here in a minute, though, when we talk about the other kind of random variable. When you're looking at it on the number line, notice on the number line, it just have dots. Dot for 0, dot for 1, dot for 2, dot for 3, dot for 4. Those are the possible outcomes. What's not a possible outcome if we're dealing with discrete random variables? Give me something on our number line that would not be a possible outcome. 1.5. 1.5. All right? No decimals, no fractions, nothing in between. It's just the whole numbers this time. If we're talking about phone calls that Gage made, can he go to his boss and say, hey, I made 4.5 phone calls today? What's his boss going to say?
Did you make a half a call?
How in the world did you make half a call, Gage? Explain it to him. And his boss is probably going to act like he's listening for about the first 10 seconds, and then he'll do
He's gonna get rid of.
he'll do what I do about half the time with you guys, right? Shake my head a lot and say, oh yeah, I understand. Not hear a word you're saying.
You don't do that to me, do you?
What?
You don't do that to me, do you?
What? So that's discrete. Discrete, when we can actually count the possible outcomes. And again, as we go through this, it'll make more sense the farther we go, because when we can compare the two, then you'll understand the difference. The other one, continuous. A continuous random variable. And again, the key thing is this right here. Instead of being able to count it, it's something that we're probably going to have to measure. Notice as you write this down on the number line, now that 1.5, does it work? Yeah. Do we really want to try to list out all the possible outcomes for a continuous random variable? As a matter of fact, is there any way for us to list out all the possible outcomes? No. It's impossible to list out all those. This chapter is going to deal with discrete random variables. Then next chapter we'll get into continuous random variables and how you can deal with them. Now we talked about Gage making phone calls. We can count up how many phone calls he made, right? Can we count up how many hours or minutes he spent on the phone?
Yep.
Sorta. Is that something that we could list out? No, because it'd be way too many of them, right? It'd be like, he spent 1 minute, he spent 1.5 minutes, he spent 1 3/4 of a minute, he spent 2 minutes, he said, so on, so it'd be a whole bunch of them. So if we're looking at our classroom here, discrete or continuous, if I'm counting up possible students.
Discrete.
Discrete.
Can't be a half one of those.
Right. Sometimes I wish there was half of some of you, but That's beside the point. I shouldn't have said that, should I? Riley's gonna run home today and say, Ebersole's wanting to cut me in half, he's some kind of psycho killer or something. Your dad would believe it too.
Already cut his brother.
They cut his brother into eights. They cut his brother into eights.
See, if your brother was in here, I probably would have said that to him. I mess with him all the time now.
I miss Zach. I put his leg on one time.
If we were trying to figure out the amount of water in Sean's bottle over there, discrete or continuous?
That's the screw you can tell. It has a.
You're measuring it.
Continuous.
It's continuous, isn't it? Because if he took a little sip out of it right now, does that mean he took a whole ounce out of it? No, so it's gonna be continuous. So, discrete, continuous. What we're gonna deal with, this chapter, everything's gonna be discrete.
Is that why it's called discrete? Probabilities.
Example, decide whether it's discrete or continuous. The number of stocks in the Dow Jones Industrial Average that have share prices that increased on a given day. Is that something that we can count or something that we have to measure?
Count the number of stocks.
We can count the number of stocks, can't we? And that's what we're looking at. How many stocks actually went up? So is it discrete or continuous?
Discrete.
Discrete. Because we can count the number of stocks.
But can't you buy like 45?
Now, they weren't talking about buying different stocks and how you could buy them. They were talking about how many stocks went up on that day. And we can count 1, 2, 3, 4, 5. And we can't say 5.5 went up, because that doesn't make any sense, right? The volume of water in a 32-ounce container, discrete or continuous? Continuous. Could be 32 ounces, could be 31.5 ounces, could be 31 1/3 ounces, so on, so on, so on.
Give them water.
Discrete probability distributions. This is what you got to do to make one of these. Oh no, this is not what you do to make one. It's got to satisfy these two conditions. Every single discrete probability distribution's got to satisfy these two things. So every time there's going to be several problems on the next test that should be easy problems on this homework also. And all you got to do is check to make sure it fits both of these two things. And you could probably, I don't know, just like the other stuff that we did, if you can understand those. This one just says it's got to be between what? All probabilities have to be between what? 0 and 1. And all of them have to add up to what? You told me that earlier. What's all the probabilities have to add up to?
1.
1. Massage in your head. See what? You couldn't feel it? I guess you can't. You can hear it? You can hear it. I guess that makes sense. It's not actually moving. It's just,
Easy as where has to look for.
do I? What? Don't worry, Phoenix Gauge is listening to everything you say. Huh?
Video.
Phoenix forgot your guys' donuts too that I was gonna share with you. Yeah.
We never shook, so. It's not a bad thing, shake. I did not get a 90.
You were close.
want your donuts. What do I want?
My homework? You get that sometimes. It's like donuts, it's like a,
No.
it's like,
It's like a treat
it's
you
a
get
sweet treat you
sometimes.
get sometimes. Some mornings you get them, some mornings you don't, you know?
Right. Somebody help Phoenix out. What happens as we go along in a math class? Does it get easier or harder?
Easier.
Easier.
Algebra 2 got easier last year, going forward.
That, I really,
Tail algebra 1.
No, I didn't.
I really can't reply on that when I'm recording, so let's not even go there.
I'm bad at algebra 2, so like.
Let's not even go there. We won't even
I probably struggle at transition.
I wish I took. That's why I wish I was in transitional math. I'd be like the smartest one in there besides Bo.
Bo doesn't ever show up.
Bo takes like 3 different math classes.
It's because he's trying to get a math credits to graduate.
What's it called?
Another
Hey,
one of
math
those things
sucks,
that I
dude.
can't
Some people are
do.
just not good with numbers.
Apparently I'm advanced in it. I don't know, like advanced, but.
This school's told me I was gifted at science for years now.
Discrete probability distributions, exactly what we're gonna do. We're gonna make a probability distribution like that. Every single time, all your probabilities gotta be between 0 and 1, all right? You can't, or I shouldn't say between 0 and 1, because can it be 0?
Yeah.
Yeah, can it be 1? Yeah. So it can be 0, it can be 1, and all of the probabilities have to add up to 1. So when we're making that, this sum over here, which you told me earlier, always has to be 1. Does the frequency sum always have to be 1? No, frequency is just how many times it occurs. All right? I'm sorry. That makes it clear. I don't know that we really need to write down all this. To make that, hopefully you have some idea when you're making a frequency, not a frequency distribution chart, a discrete probability distribution chart. When you're making it, this first column is going to be your X. That's going to be the different things. A lot of times you'll notice here, I forgot, 0. Sometimes 0 is a possible outcome. Okay? If I say number of students who got A's on the test, could 0 be one of the possible outcomes? Yeah, could have been 0 students. So, so that could be one of them. So you make your frequency distribution with your first 2 columns here. You know, count up how many got whichever one. Find the sum of the frequencies like we did down here. Then find the probability for each one of those. Add them all up and they should always add up to 1. Now when you're doing something like rolling a die, not too hard, because what's the probability of rolling a 1 on a die? 1 out of 6. Oops. What's the probability of rolling a 2?
1 out of 6.
1 out of 6. So on, for all of them, right? Is it always going to be that way? No. If we go back to a test and we do probability of getting an A, probability of getting a B, probability of getting a C, probability of getting a D, probability of getting an F, right? Are those probabilities going to be different? Yeah. Which one should have the higher likelihood of happening? Probability of getting a D?
It's easier.
Oh, that's easier. I don't see. C should be the highest one, right? Because that's the one that should occur the most. That's the average. So C should occur the most, then we could figure it out that way. To know that, we'd have to have some more information. I think they're gonna have any trouble making these charts?
Yeah, probably.
They're gonna give you most of the information, right? They're gonna tell you like,
I mean, honestly.
hey, what's the probability that if we go back to Gage and making phone calls, say there's 15 people that work at his job, and what's the probability that they made 0 calls in a day? And they're probably gonna tell you. Or if they don't tell you, they're gonna say, they're gonna give you a chart like we just had with the sophomores and credit cards and stuff on the test. They're gonna give you that chart and say, this many people made 0 calls, this many people made 1 call, this many made 2 calls. And then you're gonna have to find the probability by saying, all right, this number out of total, so on and so on. So this is what it's gonna look like. We flip a coin, and we flip that coin more than once. Apparently we're gonna flip it 3 times. And we want to know the number of tails. We could get 0 tails, we could get 1 tail, we could get 2 tails, we could get 3 tails. Those are all different possible things. Probability of getting 0 tails. Could we list it out and do something like list out the total sample space and go heads, 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 tails, heads, tails, heads, heads, tails, tails, so on, so on, so on? Could I list out all those and find the total possible outcomes? Yeah, I could. I don't really want to, but apparently there's how many of them? Oh, this wouldn't be too hard. Apparently there's 8 of them. So 1 out of 8 times we're going to get 0 tails. That means we got all heads. That would be this one. 3 out of 8 times we're going to get 1 tail. That would mean like this one, or this one, or there must be another one, and the rest of them. 3 out of 8 times we're going to get 2 tails. Be like this one, and there must be a couple others over here that I didn't list out. All of these, again, should total up to 1 whole.
Are we gonna ever do like a distinguishable type thing like this? Where it wouldn't all add up to 1?
All of these should add up to 1 every time for this stuff. It should add up to 1 every time. Otherwise, it's not going to work out. So we're dealing with certain events. So instead of just flipping a coin once, now we're flipping it 3 times and trying to figure out, all right, what's the probability that this happens, this happens, this happens, this happens. Or last chapter we had that one about the doctor doing knee surgeries or something at some point, right? I think it was on one of the examples or something. And what's the probability that the doctor has 1 success out of the 5 that he does that day, and 2 successes, 3. And that's what we're doing here. An industrial psychologist administered a personality inventory. Probably wouldn't want to do that in this class, would we? For passive-aggressive traits to 150 employees. Individuals were given a score from 1 to 5, where 1 is extremely passive, 5 is extremely aggressive. A score of 3 indicated neither trait. Construct a probability distribution for the random variable x, then graph the distribution in a histogram. So we're going to also have to still make histograms for these, except these histograms now are going to have percents or decimals on the side instead of just frequency. So first thing, if we have this, so this is exactly what you're asking, Brittany. They're going to give us this chart. Score of 1, how many people scored 1?
24.
24. How many people scored 5? What are we gonna have to do with all of these? Somebody add all those up for us so we can make this here real quick.
One fifty.
Oh, they told us up there, didn't
I just trying to do the math in my head.
How are we gonna find the probability of each one? So 24 divided by 150. Somebody help me out. Let's just do the decimal. Let's not do the percent.
16.16.
0.16. 33 divided by 150. 0.22. 42 divided by 150. 0.28. 30 divided by 150. 0.2. I'll take 0.2 over just to keep it uniform here.
0.14.
21 divided by 150 is 0.14, you said?
Yeah. Hey, drop something.
What are we gonna do with all those?
Add them up.
Add them all up and let's see what we get. One. So did it work out? Now, sometimes as you round these off, is it gonna be messed up? If it is, unlike in the last one, we sort of wanna go back and try to figure out, okay, where did we round at? And maybe bump it up or down that 1 notch or 2 notches to get it so it totals up to 1 whole. Alright? That's our chart. It's that simple to make the chart. Now, if we're gonna make a histogram, our histogram is gonna look like this, just like all the other histograms that we made. On the bottom down here is gonna be our X, which was their score, right? So what do I need along the bottom? 1, 2, 3, 4, 5.
135.
And we want the bars to touch along the side over here. What's our decimals? And you could change it to percents if you wanted. And just go percents instead of decimals, I don't care.
Probably go by 5.
Go by 5s maybe? And let's go, we'll go probability, and I'll put percent. Let's go by percent. Do we wanna go by 2s or 5s?
2s.
2s? If I go by 2s, then I got 2, 4, 6. I might be getting a little close there now. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. How high do I need to get? 24, 26, 28, 30.
That's good.
Is that pretty good? So that didn't work out too bad. And then we just make our first one. How high does that go? 16. So 16 would be right about there. It's a terrible bar, but then 22, about there. Can't make a bar like that. Then 28. Probably want to draw a little better in Ebersole because his 28 bar looks like it's about 10 times bigger than all the other bars, and it's not supposed to look that way. 20. 14. That'd be our histogram. Same stuff we were doing one extra step there, because you have to find the probabilities. Oh, I have this daggone thing up here, could have been in here instead of. Probably histogram too. Gotta do all that. A lot of times in the book, they write them sideways like this. Why, I have no idea. I think whoever wrote this book, Larson and Farber, or whoever it is, probably Larson wrote a few of the chapters and Farber came in and wrote some of them. So they switched the way that they started making their charts. This chapter, they start making their charts sideways now instead of the way we've been making them this way all year. Don't let that confuse you. This still means the same thing. It's just turned. But they write a lot of them this way in this chapter. Still gives you the same answers. I did all that. Did our histogram look something like that?
Yeah.
It was just a little uglier, but they went by fives too. What did it do when they went by fives? What did it make their histogram look? Made it sort of look shorter and fatter. All right. Are these probability distributions? The first one. What are the two things we're going to check? See if it's a probability distribution. What are we going to check? Add up to 1, and if all the probabilities are between 0 and 1. All these probabilities between 0 and 1? Yeah, so that works. Do they all add up to 1?
No. Yes.
You know that simple.
No.
They do.
Yes, they do.
They do?
Yeah.
So is that a probability distribution?
Yes.
This one, all these between 0 and 1? Yeah. Do they all add up to 1?
I'm gonna go out on work and say yeah. Crap. Mental. I'm gonna say no then.
Hey, I was about to say you're wrong again, 'cause it does.
Remember Phoenix's first theorem?
If you think more.
You get better.
Grab a hold of this, quit letting it be lonely, and just do it real quick.
It adds up to it.
So that adds up to 1, so those are both probability distributions. How about this one? How can we figure this out?
Well, they're all under one.
Are they all under 1?
0.2
Or
plus
between 0 and 1?
plus 0.4.
So you might want to go through and do what? This one is
20,
0.2,
0.1,
0.1,
0.4,
0.4,
0.1,
0.1, 0.2. Do what with all of them? Add them all up,
No. It added up to 11.
adds up to 11.
10.
Adds
Yeah,
up-
that's 10.
Yeah.
Adds up to 10.
Yeah.
Man, I just need
Thought it was supposed to add up to 1.
It's 1.
It's 1. So is it?
I just need to go.
Attaboy, Gage.
The only thing that's getting me is.
It's because you went to school on Monday.
Yeah, that's why.
Did you went to school and I didn't?
What would we have to do on this one?
Yeah, that's good.
That would have been a 5-day
That's
weekend.
pretty stable.
All right, this one you might have to, a little more trouble, right? But they're gonna give you stuff like this. You'd have to figure out what each bar is.
Whoa.
Like on this bar,
So many.
this bar looks like what? Looks like 0.05. How about this bar?
0.01.
And you'd have to decide which one that is and make a decision from there.
Why don't they just number it for us?
They probably will on most stuff like that.
Just notes again.
Mean and theoretical average. Mean or theoretical average. Now we're into the stuff that's gonna maybe be a little more difficult, a little newer. gonna find the mean of each of these, and that mean, let's just write this down now. Because this is gonna be in the notes at the very end. It's also called the expected, sorry, I can't spell, expected value. What do you think that tells you?
The value that's expected.
The value that's expected. So if we did this over and over and over again, this is the value that we'd expect to get. Now, does that mean it's gonna happen all the time? No. But if we kept doing it over and over and over, right, with the coins, if we kept doing the coins over and over and over again, we'd expect that we're gonna get heads what percent of the time? 50. Does everybody remember all these symbols? Yes. That's mu, that's the mean. It doesn't matter if it's mu or x bar. That's gonna be our mean for these. And this is the sum of x times the probability of x. So when we're looking at this right here, we're gonna take x, which is 1, times that. 2 times that. 3 times that, so on, so on, so on. And we're gonna write that down in this column.
Wait, so it's not the summation of all frequencies by that?
Right, but then, so we're gonna write them all down right here, and then down at the bottom, we're gonna do what with them? Add them all up. And that's what this chart's showing us. So on this chart, I'm not sure how that got here.
It's the same thing.
Yeah, I'm not sure why I moved it in there like that. And it's got saved somehow. On this chart, this shows us a bunch of different stuff that we're gonna do with this. Some of it we're going to do, and it's gonna help us to find the variance and the standard deviation. So just like the charts that we did at the start of the year, the bad thing is now we have to use these charts. So please draw this chart in your notes. You got this, then this column, this column, this column, this column. And I'll explain what each one of them are here in just a minute. Remember at the start of the year when we got to this point, what did you use? Your calculator. So this chart's just showing us how we're gonna work our way through this. This right here, that's your mean. So when you get to that point in the chart and you add all those up, that's the mean or the expected value of your whatever it is you're doing. So if we were doing this, our expected value might come out to be something like 2.8. So we would expect if each one of you took this test, that test that they were talking about giving each person, that you would score about a 2.8 on the test. That would be the expected value. Now, is it possible to score 2.8? No, you could score a 1, a 2, a 3, a 4, or 5. That's it. But we're expecting that you're going to be somewhere around 2.8. What do you think happens to those people who score, if 2.8 is normal, what do you think happens to those people that score a 1 or a 5?
People that score 5 again,
They probably don't hire them or fire them or let them go or whatever. The rest of these, we're gonna use here in just a minute. Remember that this is our mean, mu is our mean, so we're gonna take each x, subtract off the mean, write that down, and then square each one of those answers, write that down. Then we're gonna take this column, right here, times this column, and that's gonna give us this column, and we're gonna add all those up, and that's gonna do something for us also. Nothing hard about these except they're long. Take a little while. You gotta make sure you use your calculator. Probability distribution, this is the one that we just got done doing on the personality inventory. We found all that stuff already. Oh, I'm sorry, we didn't find this column yet. So we take 1 times that, we get this. We take 2 times that, we get that. Same thing that we had up here. We get these numbers. We add all those numbers up. What is that? 0.6, 1.44, 2.24, 3.94. So 3.94, I think. So what do we expect the person's going to score on this? I don't see it right. Did I add them? 0.6, 1.44. Oh, 2.94. Did I say 3.94? It's 2.94. So what would we expect the person's going to score on this test? Between 2 and 3, somewhere around there. That's the mean, just by adding all those up. Variance and standard deviation. Mark this one out. We did they had the shortcut earlier this year too, and we marked it out. Get rid of it. This is the formula we're going to use. That's why it says use this one. Once you find the variance, how do you find the standard deviation?
Square.
Close.
Square, take the square root.
Take the square root of it. What's sigma mean again? Sigma.
Oh, it's sigma, my bad. That's the total for the pop.
Standard deviation. What's sigma squared? Variance. Of a population, right?
This calculator give you standard data,
Do what?
Does it give you
It
variance?
doesn't give you either one for this.
Oh, that's nice.
But that chart that we just wrote down, it does. Which I guess your calculator is going to, because you're gonna have to add to do that chart and stuff, so. Don't make this harder than it is. And I know you guys won't, because you're not my sophomores or freshmen. So as everybody else sees stuff like this, they go, oh my God, how could, what is that? Because all they can think about is Bugs Bunny and on his chalkboard with the mad scientist. This is the kind of stuff you've seen, right? Phoenix doesn't remember Bugs Bunny. That guy right there. You never seen the one with the mad? Never seen the one with the mad scientist and they got all the stuff written on the chalkboard?
No, that's like 5 from your time. I'll watch the Kid Looney Tunes.
Yep. Baby ones.
Yeah.
They'll have it. You ever watch Big Bang Theory? I watch that just so I can see what's written on their boards to see if it makes any sense or not. And sometimes it's pretty good. Sometimes I'm looking at it going, that symbol doesn't go with that stuff. Somebody erased something and stuck something else in there just to screw with somebody.
Do you say that to like people watching it with you? Like, that's what it's going there.
I don't know why. Shit theory. So with this is what, again, your chart here, add to your chart. When we get out this far, you're gonna add this up. That's going to be your variance. That is your variance. This one back here is your what again? That's your mean. That's your variance. What do you gotta do to find the standard deviation? Take the square root of that variance there at the beginning.
Yeah. Hey, you should tell Thompson to get a job. He's blown up like a cat. He does have a job. He's still needs to go to job.
Go ahead and check on square root of the variance.
To get the standard deviation.
That man tried to trade with me. He was so happy. Are we doing that? I said, I go.
I go to PT 9 months ago. I think I come back like a week or two. Then I go to my appointment. I've been gone for 4 years. I'll come back to the top.
Loophole. Who cares if you cheated on it?
Guess I thought I was gonna do it, but I can't find any of the problems.
I told us if we did it would work today. I'm walking out. So we'll see if we do it. Hey, what time today? Well, okay, so he told me, I told him I wasn't showing up at all. And he told me that he'll take it easy on us if I showed up, so I showed up.
He did not take it easy on us.
He lied right through his teeth.
But that's also an easy Fey workout.
That is not easy. The football workouts were easier than mine. We had like
Well, yeah,
four
'cause we
core
had football
workouts.
practice after.
But like, a workout, that's an easy
Did you go to
Fey
weights
workout.
last year? You're not gonna kill us before football.
I mean, you go to weights last year?
I didn't even play
See,
last
that's
year.
why.
No, like weights.
We didn't do no weights for
Or
baseball
some-
either.
Yeah, you did.
But I didn't go to those either.
Those were the worst.
Oh my, I wanted to like,
So
Yeah.
much.
running when it's -10 out.
Yeah, it was 30 degrees out. It was like, alright.
This is how much.
That sounds like a normal track.
That's the whole month.
Yeah, but see, you signed up to run.
Yeah.
I did not sign up to run.
Probably.
Didn't sign up to do
That's
it.
the assignment, page 199, 35, 36, 38, 39. It's making this chart. All right, so just write it down. I wanted to get it in real quick before I forgot about it. You're making this chart. Again, Ben asked a good question. Once you make this chart and you get down to this point, that's going to be your variance. What do you got to do to find the standard deviation?
Square.
Take the square root. Brian, I'm going to take that.
Hey. Hey.
Grandma needs to get
Hey.
something for me, though.
He just skipped the calculator for you. I'm watching the video. It's the only one I watch. I'm gonna pause it right there.
Yeah, I didn't even get to.
199, 35, 36, 38,
It's in red.
36, 38.
35, 36, 38, 39.
The expected value again, the expected value, you've already got this down, it's the same as the what? Mean. Expected value is the same as the mean, all right?
Okay. I should probably write that down.
Expected value, and.
Remind me, we'll talk about that one next time. ignore that.